In an exponential equation, variables occur as exponents. So we have these types of problems. Solve the exponential equation. And the way we solve it is we need to convert 125 into a base raised to a power. And the base needs to be the same base as what it's equal to. So we need to convert 125 into 5 to the power of a number. Okay? And so how many times do you need to multiply 5 by itself to itself by to get 125? That's 5 times 5 is 25, times 5 is 125, right? So 3. So we could say 5x to the power of x is equal to 5 to the power of 3. Now that we have the same base on both sides of the equal sign, we could set their exponents equal to each other. So we could say x is equal to 3, and that is our final answer. Okay, so that's the strategy we're going to use. Let's do it over here on number 9. We need to convert 144 into the base of 12 to the power of a number. So 12 times 12 is 144. So that means we are going to convert that into 12 to the power of 2. So let's rewrite the equation. 2x plus 3 is equal to 12 to the power of 2. Now that we have the same base on both sides of the equal sign, we could set their exponents equal to each other. And we could say 2x plus 3 is equal to 2. We'll solve for x by subtracting 3 from both sides of the equal sign. We get 2x is equal to negative 1. And then we're going to divide by 2 on both sides to get x is equal to negative 1/2. And that's going to be our final answer. And I'll put a box around it. Alright, let's go ahead and look at this last problem here. The radius r of the nucleus of an atom of mass number A is this expression. R is equal to 1.2 times A to the power of 1 over 3 femtometers. Find A if R is equal to 3.6 femtometers. So our first step is we're going to substitute in 3.6 into the equation for R. So let's do that now. 3.6 is equal to 1.2a to the power of 1 over 3. Now we want to divide both sides by 1.2 to get rid of the coefficient. And we're going to be left with 3 is equal to a to the 1 over 3. Okay. Now that we're here, what we're going to do is we're going to play a little bit of a math trick. We're going to take the left side of the equal sign, and we're going to say 3 to the power of 3, all to the power of 1 over 3. Right? What are we doing here? This expression is equal to 3. Right? Why? Because we know that we could take these two powers, right? Power to a power rule. We multiply them together, and we'll get 3 over 3. So 3 to the power of 3 over 3, which is 1. So 3 to the power of 1 is just 3. So these two terms are equal to each other. Okay? But notice that by doing this, we have the same exponent on the left side of the equal sign and also the right side of the equal sign. Okay? So since we have the same exponent, now we can go ahead and set the bases equal to each other. Right? So what we can do is do 3 to the power of 3 is equal to a. And 3 to the power of 3 is 3 times 3 times 3. So 3 times 3 is 9 times 3 is 27. So a is equal to 27. And I'll put a box around that. So not only can we have the bases be equal and set the bases be the same and set the powers to each other, equal to each other, we can also set the powers equal to each other, then set the bases, I get the powers to be the same, and then set the bases to be equal to each other. to solve for a variable.